Okay, a second statics problem. This one I'm giving to you because there are two different ways to do it, and it looks a lot like the center of mass problems. Right now, assuming the pen is a simple rod in this drawing here, and that it's 10.1 centimeters of it is to the left of the edge, and 9.9 centimeters is to the right, meaning the center of mass is displaced by 1 millimeter to the left. The question is, how far right of the table edge can the ant crawl before the pen tips over? Right, so relatively straightforward problem. I want to know how far right of the table edge a 1 gram ant can crawl on a 20 gram pen before it tips over. The first method would be to set the center of mass position equal to 0. And 0, I mean the edge of the table itself. Right? The moment the ant gets the center of mass that far to the right, any further, he's going to tip it over. Alright, so 20 grams for the pen times negative 0.1 centimeters for the displacement of the center of mass, plus 1 gram for the mass, times x, how far it's crawled to the right, divided by the total mass of 21 grams, will give you an x of 2 centimeters. Right? 2 centimeters times 1 equals 20 times 0.1. Divide by the total mass, which doesn't matter because it's equal to 0. This method is mathematically equivalent to setting the sum of torques equal to 0, where you have a 20 gram center of mass, or mass, acting at a center of mass position for the rod of a millimeter to the left, plus a 1 gram mass for the ant acting at x centimeter to the right. Right? You can see that I can just cancel the 21 grams on the bottom there in the center of mass equation because the whole thing is equal to 0. Right? If I multiplied both sides by 21 grams, I would just recover the sum of torques equations. Right? Mathematically the same. This is a pretty easy statics problem, pretty straightforward. Common mistakes. Oversimplification. Some people will somehow oversimplify this even though the equations are really, really simple. Or I've seen people take the distance this center of mass was displaced to the left and divide it by 2. I don't know why they divide by 2, but they seem to insist on it all the time. Forgot that one when I was writing down the common mistakes. Misuse of the center of mass formula. Okay, that probably accounts for dividing by 2. Right? So take a good look at this problem, because a problem kind of similar to this or the mountain climber problem will be appearing on exam 2. You're going to get some statics, you're going to get some rotational energy, you're going to get some angular momentum. These things you can be guaranteed. I like to cover all the subjects if I can.